Okay, so this is number 19 on the complex packet, and I really, really don't like this problem. Uh, I actually didn't even solve it. Actually, this was the credit to Jack and Levi for solving this one. But um, we will see if we can walk through this and how you try to get this value. So ultimately, we're trying to find this value right here. Now, through trying a couple different ways, it seems like this is the best route is to actually extend the triangle from this point right here out to here, up to there, over that way. We're going to call that the red triangle, okay? We're going to have another overlap. We're going to call this the green triangle right here. That's going to go from here, down there, over here, and back up. That's the green triangle, and then we're going to have one little triangle that's kind of made from that, which we're going to call the blue triangle, which is this right here. So those are the three color triangles we're going to work with, and we're going to try to see if we can reason this out. Now, the first thing you're going to need to do is you're going to take that red triangle and realize that in this red triangle, this angle right here happens to be the same as the angle given to you right there. Okay? And that angle, okay, if this is a 90 here, which it is, okay, which it is, that means that this angle is the complement of that angle. So this blue triangle angle, or this angle right here, is going to end up being 90 minus the given angle. So 90 minus the 54.5 is going to give us our angle of reference, which is 35.5 degrees. Now that's this angle right here, as I'm talking about. So that red angle, which is also shared with the blue. Now, we need some other values for this. Now, we're given the hypotenuse to be right here. This is the length of the hypotenuse of the red triangle. So I'm going to redraw the red triangle, and we are going to solve ultimately, we'll call this Z. We're trying to find that value right there. So we're going to call this 35.5 degrees. This diagonal is going to be 1.187, and we're going to try to find that. So if you look at that, that's going to end up being a cosine. So if this is adjacent, that's hypotenuse. So Z is going to be equal to the hypotenuse, 1.187 times the cosine of my angle, which is 35.5 degrees. Okay, work that out. When you work that out, you get 0.966. Okay, so that is from this corner where the blue and the red share all the way out to this corner right here, which is kind of an important piece because we're going to end up needing that from there back. So we'll worry about that in a bit. So their red triangle's done. That's really, really good. So now we're going to move ourselves over to the blue triangle because this becomes really, really important and for us to solve the green triangle. So the blue needs solved to solve the green. And here we go again. So this is, again, very hard problem. Not one of my favorites by any means, but kind of good problem to practice in your trig and some of your blueprint reading. Okay, so you got that angle right there. And we know some things. What else do we know? We know this diagonal is this measurement right here, which is right there. Okay, so that this diagonal is 0.157. So that's going to be, and ultimately, now we're trying to find this value. We'll call this a y. Okay, we're trying to find y, so y is going to be equal to, that's going to be opposite of our hypotenuse, that's sine. So y is going to be the diagonal 0.157 times the sine of 35 degrees, and as long as my math was right on my paper, you should get 0.091. Okay, so that's the blue triangle down there. We're going to need that piece. All right, so that's our y value. Now we're going to go to the green triangle, and this is where it's all going to kind of come together. So our green triangle looks like this. We know this angle to be given is 54.5, and that's because it's 30 minutes, not degrees. So 30 minutes is a half a degree. So 54.5 is our angle. And I know that this side of the green is going to be this piece right here plus the height of the blue, or what we were calling our y value. So this piece plus the height of the blue, which is the y value, gives me this piece right here. So that's going to be 0.091 plus the given value, 0.312. That's going to equal 0.403, which is this side of the triangle. Okay, now we know an angle, and ultimately on this green triangle, I'm going to try to find this value right here. We'll call it, let's call it A. Why not? We'll call it A. Okay, so we're trying to find A. So that's going to be opposite over adjacent. That's a tangent problem. So you're going to end up going with the opposite side, which will stay on the top, 0.403, divided by the tangent of, and that will give us our A value, divided by the tangent of 54.5. I'm not setting that up because this is the complex packet. You guys should know this together. So you work that out, and you get 0.2876. All right, that's a really important number. We're going to use that number. So that number is from here to here. Okay, that's really good. So what I'm going to do now, and I'm going to use some highlighters to kind of show you what I'm talking about here, is we are going to take this value right here away from this value in red, and that will essentially give me the distance here in blue. Okay, that's going to be really good because we're going to use this. Okay, so here we go. We're going to go yellow minus green will give me blue. Yellow minus green will give me blue. So let's do that. Yellow value, okay, is our value that I called Z in the beginning, which is 0.966. We're going to take away the A value, which is 0.2876. That's going to give us 0.678, and that's really good because that's my blue value. So this distance right here is 0.678. Okay, now that's really good because I can subtract it from this guy, which is what I'm going to do next. So we'll go. Let's go with a color we haven't used. We'll go pink. All right, so pink. We're going to go 1.780 take away 0.678. Okay, that's going to give me, what is that going to give me? Oh, that's going to give me 1.1. All right, so it gives me 1.1. All right, which is good. So we know it's 1.1 in purple from here to here. Now we can get back up to the top of the print. We're going to take out this in purple right here, and that will leave me with that, which is my X value. Okay, so 1.1 take away this gives me that, which is what I want. Okay, thank God. All right, so it's going to be 1.1 take away 0.562, and we get to our answer of 0.5396. It's a 5. It's a bad 5, but it's a 5. Okay, and that's your answer. So you're done. That's a yeah, that's a tough problem. That might be the toughest one in our packet, guys. So that complex number 19, that's all said and done. Good luck.